Quantitative structure activity relationship models, QSAR models, are regression or classification models used in the chemical and biological sciences and engineering. Like other regression models, QSAR regression models relate a set of predictor variables, X, to the potency of the response variable. Gather your data as presented below in the table. Start by collecting the data points. In this example, we chose 5 inhibitors. Quantum parameters include HOMO and LUMO energy, total dipole, adsorption energy. Experimental data include inhibition efficiency, i.e., % and inhibitor concentration. Based on the nature of your data and the relationships you want to capture, select an appropriate equation form. Based on the nature of our data, we chose the Lukowitz model is a nonlinear model, which was it evolved from Langmuir's adsorption model. Based on our data, we put 4 quantum parameters into the equation. Thus the new form of the equation become. Determine the fitting method. There are different methods for fitting equations to data, such as the least squares method or maximum likelihood estimation. We chose here the least square method. Implement the fitting algorithm. Use a programming language or a mathematical software package to implement the fitting algorithm. This could involve minimizing the sum of squared residuals or maximizing the depending on the chosen fitting method. Here the solver in Excel were chosen. Perform the fitting. Apply the fitting algorithm to your data. The algorithm will estimate the values of the variables in the equation that best fit the data points. Assess the fit. Evaluate the quality of the fit by examining the R-square. Plot experimental data versus predicted data to see how close experimental data to predicted data. As we gathered our data here and we organized as showed in spreadsheet. Inhibition efficiency. Concentrations. HOMO. LUMO total dipole adsorption energy. We put the equation parameters here. And then we program our equation to look like this. After our equation we set then make square differences between experimental data and predicted data. The main objective for the Excel solver is to minimize the summation of differences between experimental data and predicted data. When the minimum point of minimization is reached, R-square gets highest, and regression goal is achieved. In nutshell, we present the results. Document the equation form, the values of the variables, and any relevant statistical measures, R-squared, to describe the quality of the fit.